when you're doing dosimetry problems, there's a lot of terms that are used for calculations like percent depth dose, TMRs, TARs, backscatter factor, and so on. And they aren't really used in the clinic so much anymore. We used to use it more when I was first starting, but um, you definitely will get them on tests, and they're a good thing to know if you're going to be a dosimetrist. They're a good thing to know just for getting the concepts of what's happening with radiation. They can be a little confusing and hard to remember. So what we're going to do today is I'm going to show you, just give you a picture that you can use to remember at least some of these. So let's say again we've got our phantom here, and we're going to do some two radiation beams on here. These two beams are the same field size, same distance and everything. What we have over here, these two little circles, that is called, we call that tissue for an in-air measurement. And what we mean by that, in air, it's actually in tissue, but it's at the center of this. It's at the center of these two little some points here. Finished drawing these out here. They're at the center here of these two little circles here. We'd imagine this radiation coming down, and the beam will have just enough tissue here in order to cause buildup to Dmax. So the idea of these little circles here is that they're at Dmax depth, but at just enough so you don't have scatter coming in from around the tissue like this. All you have is just enough so that you're getting sort of the direct beam with a Dmax depth there. And these points over here, I didn't draw them exactly correct, but this idea would be this point is also at Dmax and this is at some depth, and these are straight across here. So here's our situation. We got a phantom with 2 points in it, and we've got these two little areas here that have just enough tissue around the point to cause Dmax buildup. And we're going to get out of this, we're going to get 4 different factors that you might see in calculations. All right, so the first 2 points we're going to look at are these ones over here, and we're just going to look at the difference in doses that we would measure at this point and at that point. And let's just say that this point here is at a depth of Dmax, and this point here is at a depth D. It doesn't really matter. What we're going to say, again, if we look at we'll call this one A and this one B, and we're going to look at the difference in doses between these two. The definition of the dose at B divided by the dose at A is by definition the percent depth dose. So from here to here gives you percent depth dose. All right, now let's look at the dose between these 2 points here. If we measured the dose at each of these, and we can call these 2 points C and D. Now if we measured the dose at C and measured the dose at D, and I should say technically for the dose at D here we'd have to remove the C, if that's going to be a proper in air, but we'll just ignore that for now. We'll just say that doesn't perturb it too much. But if we measure the difference in dose between these 2 points, these are in air with no extra scatter around, that is going to be the dose at D divided by the dose at C is just the inverse squared factor going from C to D. These we could actually flip around. We could say the dose at C divided by dose at D, and that would give us the inverse squared factor going back up this way. But we'll just say for the time being we're going from this point to that point. So the difference in dose between these 2 points gives you inverse squared. All right, now let's look at the difference in dose between these 2 points, between A and C. If we measure the dose here and the dose here, what would that give us? So in other words, if we measure the dose at A divided by the dose at C, that is another factor, and that is called the backscatter factor, and that is only here at a depth of Dmax in the tissue. So if you have a beam coming in here to a phantom at Dmax, and you compare that to the same height in the beam or same distance in the beam to this dose we called in-air dose, that is the backscatter factor. So it's the dose in the phantom divided by the dose in air at that same point. Alright, so our final 2 points to look at are down here, B and D. And so if we looked at the dose at point B divided by the dose at point D, that is another factor called the tissue air ratio, TAR. This one I have always remembered this just by the order it comes in. So tissue air ratio, if you take the dose in your tissue divided by the dose at air, in air, that gives you the TAR. So with this little drawing here, if you can remember that, you can get 4 of the factors and see how they're related. You can also see from this that what's called the backscatter factor is just a special case of the tissue air ratio. In other words, tissue air ratio could be at any depth. It would just be the dose at that depth divided by the dose in air at that same point in the beam, while the backscatter factor is only for Dmax. So the backscatter factor is always a TAR, but a TAR is not always a backscatter factor. So that is a good way to remember those 4 ratios. One more factor I can add in here is I don't quite have room to draw another phantom, so I'm just going to put it, let's just add a phantom like this. So let's forget we have the little in-air here, and we're just going to have a phantom here, but this is at Dmax depth here, and so that was our point B. And let's just call this one E, so it's at this level down here, but it's at Dmax in a phantom. So if we again looked at the dose at point B divided by dose at point E, that is going to be the tissue maximum ratio. And again, the way I always remembered this was I'd say the dose in tissue at a certain depth divided by the dose at the maximum ratio. So that's in the phantom. So there's 5 factors. So if you can remember this picture, you can remember all 5 of those relationships and use those if you need it, because a lot of the questions you're going to get, and you have to decide which ratios to use and how to use them, is just go back to the definition of each of those and think about what are you taking a ratio at dose at what point to what other point, and that should help you on those problems.